Hi viewers, in this video we will see about the electrostatics. Electrostatics plays an important role in our daily life. Lighting, photocopier as well as spray painting are functioned based on their electrostatic force. Electrostatics is a branch of physics which deals with static charges or charges in the rest and its related phenomena. We know very well each and every material is consist of smallest units, that is we called as atom. Atom is consist of central nucleus as well as surrounding electron. When we rub two material, automatically the charge, that is electron, is transferred from one material to another material. Automatically the material get chargified. Here we have two examples. One is comb with paper. Look at this picture. Comb always having minus charge which attract positively charged surface of the papers. In the second image, usually balloon has negative charges. When we rub the material, it is attracted by the positively charged wood surface. Understanding this electrostatic force between the rubbed surface is very important, and it plays an important role to design the new kind of devices. The force between two charges can be easily understood with the help of Coulomb's law. According to Coulomb's law, the force between two charged particles is directly proportional to magnitude of the charges, that is Q1 and Q2, as well as inversely proportional to square of the distance between charges. Now we can write force as directly proportional to Q1 Q2 divided by R square. When we introduce proportionality constant, we can write force as F is equal to K into Q1 Q2 divided by R square. Here the value of K is 1 by 4 by epsilon naught. Now we can have the force is equal to 1 by 4 by epsilon naught Q1 Q2 divided by R square. In vector form we want to add R cap. So now we can have equation F12 is equal to 1 by 4 by epsilon naught Q1 Q2 divided by R12 square R1 cap. This force is against the force acting on the another charges. Suppose if we have multiple charges, n number of charges in the system, we can write force as sum of the forces according to the principle of superposition. Now we have the overall force is equal to 1 by 4 by epsilon naught into Q1 Q2 divided by R12 square R12 cap plus Q1 Q3 divided by R13 square R13 cap, up to we can write n charges. Here we can see the electric lines of force between two charged particles. It clearly shows that same kind of charged particle always are repulsive, whereas opposite kind of charged particle always attractive each other. Also we can see clearly the force of line start from positive charge and end with a negative charge. Also it clearly represent the charged particle having the force of lines without any intersect. Here we can see the similarity between electrostatic force and gravitational force. Electrostatic force are the forces which is created between two charged particles. This also known as Coulomb force. Whereas gravitational force are the forces which is created between any object in the universe. It is called as Newton law. Both forces are similar, but it have some difference in their object. First one represent the force between charged particle, and second one represent the force between any object in the universe. We know very well the charged particle create an electric force. The electric force create an electric field. Number of electric force of lines is directly proportional to strength of the electric field. Now we can see what is meant by electric field. Electric field are the force which is created by the unit test charges. Let me consider positive charges which is situated at the O. In order to calculate the electric field, we have to place test charges plus Q naught at the point P. According to Coulomb's law, now we can easily find out the forces between two charges, that is plus Q and plus Q naught. So that is equal to F is equal to 1 by 4 by epsilon naught Q naught divided by R square. Once we know the force, automatically we can calculate the electric field that is experienced by the force with the help of E is equal to F by Q naught. Once we substitute force in the formula, automatically we can have the electric field that is equal to 1 by 4 by epsilon naught Q by R square. In terms of vector notation, we have to put R cap. Suppose if we have n number of charges, we can represent electric field as a sum of the electric field which is created by the each charges. So we can represent resultant electric field as sum of the electric field E1 plus E2 plus E3 up to n number of charges. Now we can have the electric field in terms of charges, that is 1 by 4 by epsilon naught into Q1 divided by R1 square R1 cap plus Q2 divided by R2 square R2 cap up to we have n number of charges. So we can now write it is as in the terms of summation E is equal to 1 by 4 by epsilon naught summation of Qi divided by Ri square R cap I. If the charges are continuous, we can also represent electric field in terms of integration. E is equal to 1 by 4 by epsilon naught integral of dq by r square Ri cap. Suppose if we have surface charge density, then we can also write electric field in terms of surface charge density. Surface charge density are the factor which represent how much of charges in the particular surface. Similarly, we can write electric field in terms of charge density, volume charge density as well as line charge density lambda. So far we have seen the force created by the two charged particle as well as the field created by the charges. E is equal to F by Q naught. Here we can see the application of these electrostatic charges. The first main applications of the electrostatic charges are electrostatic spray. Electrostatic spray create an uniform painting on the surface of the car because the electric gun in the spray having the positive charged particle, whereas the car is grounded, so positive and negative particle always attractive, so the paint is uniformly coated on the car. This is one of the interesting application of the electrostatics. Another interesting application is lightning. Lightning is created by interaction of charged particle. We know very well clouds are the charged particle. The bottom of the clouds we have negative charges and top of the surface of the earth have positive charges. So we know very well according to Coulomb's law there is an interaction between, there is an attraction between positive and negative charges. So we have the interaction between surface of the earth with the bottom of the cloud. That's why top surfaces easily attracted by the lightning. Now let me see how the photocopier working based on their electrostatic interaction between two charged particles. Here we can have the schematic of the photocopier. The main parts are light, donor, paper, master copy and a rotating drum. This rotating drum is specially designed because it is coated with the photoconductive material. When light falls on this photoconductive material, it creates a charged particle. When we copy the master copy, automatically drum create charges based on their signal. This charges is attracted by the donor particle, and when drum is rotated on the paper, it is printed. So far we have seen the electrostatics, how the electrostatic force will happen, how the electric field will be produced by the charged particle, and what are the application of the electrostatics. I think this video is very useful to you to understand the concept of electrostatics. Thank you.